Hi, the Ralph Wiggum Loop is very interesting because it allows you to autonomously develop code while you're sleeping. I want to take it a notch further. What if we ran the Ralph Wiggum Loop on a Raspberry Pi? That way, it frees up your main computer and you can develop really sophisticated pieces of software while you're pretty much asleep. Now, there are some things you need to know about the Ralph Wiggum Loop in order for it to be efficient. Mainly today, I'll be developing the Ralph Wiggum Loop with mfbt, which is a collaboration and brainstorming platform for vibe engineering rather than vibe coding. So let's get right into it. The idea about using the Raspberry Pi is that it sips power, usually about 5 watts of power consumption. It can pretty much run 24/7. It frees up your main machine. Of course, it's super cheap, not very expensive as well. It runs Linux, and so it's able to run a bunch of software that we need. So the general idea is, like I mentioned, can you simply run the Ralph Wiggum Loop on a Raspberry Pi and keep developing software while you're pretty much asleep? Now, there are a few things that you need to know about the Ralph Wiggum Loop. I'd say there are 4 pillars that you really need to be aware of. Number one is you have the spec and an implementation plan upfront. You put a lot of time into it, a lot of thought into it. That way you have a solid spec that you can depend on, and then the agent can essentially take up and implement. The second pillar is the loop. The loop is what can be run by an external system as it uses the coding agent to implement feature by feature that you need, that is defined in your spec and prompt plan. Next is you need persistent memory so that the agent, when it starts up at each iteration, it knows what's done so far and it can develop the next feature pretty quickly. Now, also very important in a Ralph Wiggum loop is setting up the feedback loop for the coding agent. The coding agent needs to self-correct and verify, or rather verify and self-correct. Let's talk about these pillars one by one. Now, pillar number one is the spec. It's super important to have a structured JSON or a plan file. Now, this is not easily done because of the effort involved, so you need to be deliberate about this particular step. But this is where mfbt can come in and play a huge role. mfbt is designed not only for you to create the spec, but also for your team to get involved, for AI to get involved, and for you to essentially create the spec from a lot of collaborative material. We'll see in a bit of detail how this works with mfbt. The second pillar is the loop. The plan is now available, so there is a system, some kind of a system, which reads the plan and then picks up the next piece of work, spawns an agent, and then the agent essentially finishes the task, and hopefully it does. Then the external system figures out if the task is indeed complete, and then it picks up the next tasks and so on. This is pretty much the Ralph Wiggum loop. There are some nuances here, as we'll see in the next 2 pillars. Now, pillar number 3 is using fresh context, but also persistent memory for the coding agent. Fresh context because when you go through a long PRD spec or a prompt plan or implementation plan, you do not want the coding agent to use up the whole large language model context and then go in for stuff like compaction, because that can be really bad for the quality of implementation. But also you want to make sure that you are providing small chunks of work to the coding agent. So in essence, it doesn't go into what people generally call the dump zone of 50% plus of the context window. Also, more importantly, when the coding agent is implementing, you want to make sure that the context is a fresh context for every feature that gets implemented, that gets picked up and then gets implemented. While this happens, it's also important to understand that coding agents can take a very long time to figure out what's been implemented already and all of that. So as the coding agent goes about working on your product, it's also important for it to remember what it's implemented so far, but also remember things like how to build, where each module is in the source code and things like that, which can really speed up the implementation process itself. The fourth and the final pillar is the feedback loop that you need to provide the agent. And I think this is super critical for Ralph Wiggum loops. 2 or 3 things come to mind. Number one, can the coding agent look at logs? Can the coding agent look at the JavaScript console, assuming that you're building a full stack application? Can it look at the build output? Things like that, right? But I think critical or the minimum requirements are the logs, number one, and number two, the access to the browser, where it has access to the DOM, the JS console, the screenshots, things like that. These are the four pillars that a Ralph Wiggum loop needs. So once you have this, you can pretty much autonomously write code and like I said, have your application up and running while you're pretty much sleeping. Now, the general idea with mfbt is that you go from vibe coding to vibe engineering. Now, vibe engineering is a term that denotes not one person coding sitting on a terminal, but rather collaboratively providing the coding agents the context they need to build more sophisticated applications, but also to provide context upfront for these kind of Ralph Wiggum type loops, right? And of course, because brainstorming is involved with your teammates, with yourself, with AI as well, and because the AI can access the internet, they can access your source code, mfbt can come up with very resilient specs. So now let's look at how, for instance, we can use a Raspberry Pi to achieve something like this. So we have a Raspberry Pi running here. So in essence, we want to create a new project. To keep things very simple, we will load a sample project in mfbt. Now this is a simple clone of the Flappy Bird game. It runs in the browser. So if you look at the various phases, these are brainstorming phases. So in essence, there's a bit of brainstorming going on as to what this game really entails. For instance, the collision model is being set to AABB, and then there's a bunch of colleagues who are commenting on what it is, and they seem to be in agreement, so there's no problem here. And then there's the core stack choice here. In essence, we are going with the vanilla JavaScript, right? And then let's look at other couple of phases. Here we have audio. We don't want any external assets, so we simply use the ZZFX library, which is a really good library. Then we have the audio architecture. We only use sound synthesis with no audio assets, keeping things simple, things like that. So there are, in essence, 3 different phases, right? Now, from each of these phases, we have created, based on the discussion, a spec, a prompt plan, and also a set of features. Now, each of these phases contribute a bunch of features, and all of these features are now available in the global project features list. Now let's sort by feature key ascending. So there you go. You have core, game engine, audio system, polish, and deployment. All of these have a spec and a prompt plan, but we see that these user features are pretty new, and there's no spec and prompt plan as yet. So let's go into these one by one. I'll show you how collaboration also works. There you go. So for this, we have this is essentially the settings screen. So we have audio plus difficulty plus reduced motion. So everyone agrees. So this is all good. So we can actually create an implementation from this conversation. This creates an implementation point. Of course, you can continue the feature with multiple implementation points, but let's create the spec and the prompt plan. This can continue while we go look at the other features that need attention. 10 is done. Now we go to 11. Okay. Now this is about scope persistence. So it looks like I chose local storage, but then there's some confusion with some of the product managers. Jane is asking if is local storage widely supported. Max is saying it's a good point to Jane, and then he's asking if local storage will trigger any permissions, which is not very ideal in a simple game. So mfbt AI has flagged these issues as unresolved, so we can go ahead and resolve these and tell them that this is not a problem. Or actually, you know what, we can ask mfbt AI to resolve this for us. So you can involve other colleagues. For instance, this is a great place where you might want to involve an architect, for instance, or like I said, it doesn't really matter. You can always invoke mfbt AI, and then it can figure out what the problem is, and then it can clarify things And then mfbt AI again kicks in and then figures out if there are any unresolved points. It looks like everything is good, so in essence we can just resolve this and we can keep going. As you can see, now there's no unresolved points anymore. We are all good, so we can create an implementation point from the conversation so far. This is kicked off generation of the spec and the prompt plan. Let's go back to features. There's one last, the ending screen and replay flow. Here there was some ambiguity in the spec, so mfbt AI is asking us a bunch of questions. These are all multiple choice questions, very easy to answer. So what should the ending screen display? We'll go with score plus best plus short message. That's good. Then for this, how should the replay flow work? We don't want instant restart. We want, let's say, a button click or some kind of an event. Awesome. Now this, after we answer these questions, mfbt AI is checking whether there's any other open points or gaps in the spec that it wants to address. It might ask you a set of follow-up questions, or you can involve other folks if you have a problem. But then this looks good, and so there's no unresolved points. The decisions are very clear. So in essence, we can create an implementation point here. Awesome. Now there's 3 features that needed attention, and as we can see, the spec and the prompt plans are being created one by one in the background. So we can simply wait a bit for the spec and the prompt plan to be available for all of these features and simply go from there. Awesome. Now the spec and the prompt plan have been created for pretty much all of these features. We can go really quickly in, check whether the spec and the prompt plan look good. So here's the spec, here's the prompt plan. So all good. So now what we can do is that we can go to a terminal, connect mfbt with Claude Code or any coding agent of your choice, and then start developing. But this is what we want to do. We are on a Raspberry Pi right now, of course. So we will go to this terminal here, and inside of projects I have a folder called Flappy. In this directory it's pretty much empty. There's nothing here, but I do have the Chrome DevTools MCP configured. So if I hit this command, I see that we have the Chrome developer tools already installed. Now what I'm gonna do is that I'm gonna go to settings here, go to MCP for this particular project, and copy the command that will allow me to connect Claude Code with mfbt over MCP. Here I go and I paste this in. There you go. Now we have the connection ready. Let me clear the screen. Let me look at the list of MCP servers available for Claude again. There you go. Now we have 2 MCP servers. The Chrome DevTools MCP server is there because it allows Claude Code to get feedback about what's building. All right. So now in essence, we can just start the mfbt CLI, which lists all of our projects. So this is the project that we just created. Let's go in and view what's there. So it's got all these faces, and all of these faces have modules and different features and all of that. So we have specs and the prompt plan for each of these features. So this TUI is pretty useful by itself, right? Now let's start a Ralph Wiggum loop because that's what we are here for on this Raspberry Pi. We want to implement this game, and we want to do it in a way that doesn't involve us babysitting Claude Code. So I hit R for this, and I go into the Ralph loop, right? And it allows you to look at all the different faces, and I hit C, continue, to in essence get the list of features. As you can see, all of these features have a spec and a prompt plan, but they don't have any implementation notes added yet. And then you can look at the priority, and you can look at the statuses, of course, pretty much pending, right? Now, before starting the loop, by hitting R, I want to add a custom instruction that tells the coding agent to verify its work whenever it's done implementing a feature. So let's do that. I'll hit I to bring up the custom instructions mode. let's save this. All right. So all we need to do now is, in essence, hit R, and we should be away. So hitting R lets us choose the coding agent. Cloud Code is the only coding agent mfbt CLI supports right now. Of course, you're free to use any other coding agent, because the mfbt MCP doesn't have any restrictions as to the coding agent that you can use. And some pre-flight checks are here. Cloud Code is already installed, and mfbt is also configured, so all good. So let's just hit start. Now you will be able to see that the loop has begun. Pretty much it goes through all of the different implementations. So you can also see that Cloud Code has started, and then it's basically talking to the mfbt MCP server, and then in essence it's just going to figure out the spec and the prompt plan. You don't have to add any special instructions. You really don't have to do anything, because you did see that the directory is pretty empty. There's no file, there's no other connection. The only connection between Cloud Code and mfbt, the service, is in essence the MCP server. Now, one other thing you will see is that it will test its own work. So it's trying to run the server, and then it'll also figure out if it can open it in Chrome MCP. There you go. So as you can see, yeah, lovely. So it looks like it has already implemented something, and then it's just opening Chrome and then testing it itself. Wow, there you go. So we have the beginnings of our game ready. And as you can see, we actually did nothing. We simply went ahead and simply configured the Ralph loop and let it run. Now let's go to mfbt and the features. And if you look at it, it's going through feature by feature. So you can see that this has been marked as in progress. And once Cloud Code is done implementing this, it will also add notes here. Now it says no notes, so we can wait for that and see how that's getting added. So let's go to the terminal here. It's still running, and it says that all features are verified. So now it's saying, now let me write implementation notes and mark the feature as complete. And as this happens, you will be able to see in mfbt that this particular feature, as you can see now, notes, it's added notes. And then in a bit you can see that this feature is complete, and then the progress bar just went to 1 of 12, which is great. So we can now go into this feature, and we should be able to look at the implementation notes that the system has added. So, and it's pretty much complete, right? So description, spec, of course, prompt plan, everything is already there. And now the system has added, the coding agent has added implementation notes. So here are the implementation notes, and based on this implementation notes, grounding will be updated. So if you look at the main branch, you can see that it has updated grounding information based on the implementation notes. So as implementation notes are added for more and more features, you can expect grounding to be updated. Now this grounding becomes available to the coding agent as it implements the next feature. That is super important, because as we saw, one of the main things about the Ralph Wiggum Loop is that not only should the coding agent have access to the spec, but it's always a good idea that when it starts with a fresh context for each feature that's being developed, it has warm starting information and it knows what's implemented so far, so that it doesn't have to go through the code again. Of course, we don't want to overburden the coding agent with unnecessary grounding information that it can figure out itself, but you get the idea. It's always a balance. Now going back to features, you will see that now the next feature has gotten picked up, and then the coding agent is implementing that. So let's switch over to the terminal. There you go. So this is successful, and this is in the running state now, and it should just continue like that. Now in essence, we don't have to really do anything. It's just going to burn through the full list of features, and this is on a Raspberry Pi. I can shut down my laptop, my desktop, and go to sleep, and you can expect this whole thing to be pretty much complete because of the just how good the spec is that mfbt has created. Okay, now we'll take a break, and then we'll come back after the whole thing is done. We are 40 minutes in, and we only have a couple of more features left. it's doing whatever it's doing. I want to really quickly come figure out what kind of resources we are using here. So let's hit btop, and okay, we are hitting some 20% CPU, but then this particular Raspberry Pi 5 model has 8 GB of RAM. So looks like we only still used, you know, like something like 2 GB, and so 73% is still available. Is actually not pretty bad. And this particular model has 4 cores. As you can see here, we're only using about 20% or so of it. And yeah, I can see there's some CPU usage with the mfbt CLI, with the Chromium browser and all that, also with the Claude code instance. But I don't see pretty much that this can be a problem even for full stack projects. So if you want to run a database, if you want to run a backend, even like a front end server, that shouldn't be a bit of a problem. Actually, you can develop fairly serious pieces of software on a Raspberry Pi, given that they come with 8 GB of RAM. Some of the models do. I'm not sure how if there are other models available with more RAM, but this one pretty much is pretty impressive. I'll see you back when the development is fully done. All right, so here we are, some 70 minutes later, an hour or so later, and as you can see, it's pretty much everything is done, and it's succeeded. So let's go open up, this thing in a browser and see how it works. So let's open projects, I guess, Flappy and index.html. There you go. So we have the difficulty screen, we have a setup screen, we have sound implemented. This is pretty awesome. And yeah, okay, so let me try again with the normal mode. Should be easy to play. There you go. This is perfect. Works pretty well. Okay, it's a new high score. There you go. So this works pretty well. Awesome. So let's go back to our console here. If you go to mfbt, you can see that everything is green, everything is implemented, and we have nodes pretty much. I think it missed the nodes for 008, but pretty much, everything is done. And we have also grounding, solid grounding file available here. There you go. It's pretty lengthy. It's got all the important information here, right? Back to features, we can look at the implementation notes. So let's pick a feature and then go to implementation notes. And there you have it. It's done a good job. So awesome. So I hope you get an idea with mfbt how you can have all the spec in one place, use the mfbt CLI to run the Ralph Wiggum loop, and then pretty much go away as it's implementing. And it's able to also, I think it's used this Chromium, which is, you can see this Chromium is controlled by automated test software, which is essentially Claude code in this instance. It's in the background, because we asked it to verify its work. It's essentially doing that, and then it's made sure that it's done a really good implementation. As you can see, the implementation is not bad. It's pretty decent, and you can imagine what we can do for other things. In fact, it's actually pretty difficult to test a game in the browser. But as you can imagine, if it's typical SaaS kind of software, it's relatively easy to test. And you can look at the different the features here. If you hit L, you can look at the logs of the implementation. So you can see here that it's actually using all sorts of MCP systems, right? And then if you look at let's say one more, we can look at the logs here. You can see that it's calling the Chrome DevTools multiple times to figure out how to test what it's been developing, right? So yeah, that's pretty much it. Please sign up for mfbt. Check out our GitHub repo. Please give us a star when you're there. Thank you very much for your time.